In lesson 9.3, area of composite figures, we're going to work on our standard 7.G.6, solving real-world mathematical problems with area, volume, and also looking at surface area of two-dimensional and three-dimensional objects that are made up of triangles, quadrilaterals, polygons, cubes, and right prisms. The essential question then is, how do you find the area of a composite figure? So right here you see this is an example of a composite figure. A composite figure is made up of geometrical shapes. We don't necessarily recognize them, but what I'm going to do here is I think I see like a triangle. So I'm going to draw this line here, and then I could draw a line over here. So I have a triangle, I have a rectangle, and I have a second rectangle. So I got three figures, three geometrical figures that I've put together, and that's called a composite figure. So in this activity we're going to look to find how we can come up with the area of a composite figure. And one of the ways that we can do this is that we start to recognize if we have a shape in here or not. So like I said, this is a triangle, and then I draw across here, and then what we do is that we simply count how many squares. So like here I have 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8. So that's 32 squares. And then I get to my triangle. So what do I do with my triangle? Well, there's a couple techniques that you can do. If you remember, if the triangle here, I put it in 2, I could count 1, 2, 3, 4, 5, 6, 7, 8, and then I cut that in half. Okay, so half of 8, I divide that by 2, and that equals 4. So this piece here is 4, and this one also would be 4. Or I could take those and I could draw this triangle here, and I could turn it upside down and place it. I now have another rectangle, and then I just count that out. 1, 2, 3, 4, 5, 6, 7, 8. So that gives me 8 because these two added together, 4 plus 4, that equals 8. Then I go ahead and I add them all together. So I have 8, I have 32, and I have 6. So 32 and 8 is 40, and I have 6. My area then is 32 plus 8, that's 40, plus 6. So this is 40 plus 6, so that equals 46, and then I have square meters. Here in the reflect, they ask you to use dotted lines to show your different ways. So basically you're going to come up with different ways of what we did on the up above on how you could represent this in different shapes. On the next page, you want to take special attention to this here, okay? Put big asterisks like we've done before, you know. They give you all of the formulas for a triangle, a square, a rectangle, parallelogram, or a trapezoid. Now, these guys here, they use different things, but simply is area equals length times width. S is for side, okay, because on a square you only have one side, and being a square, all four sides have to be the same. So if this is a side of 2, that has to be a side of 2, and so forth. Rectangle is length times width, and a parallelogram is pretty much the same thing. It's just been slanted, okay? So it too has length times width. But here they use B, which stands for base. And then they have H, which stands for height. Same thing. Base times height, length times width is all the same. And then you have your trapezoid. Of course, remember this is what a trapezoid looks like. So this is the height. This is base 1. This is base 2. And then this is your height going up here. And that would be the pieces there that you would have. So in this example, they have several examples that you can go ahead and use. You take a look here in this example 1, we have a parallelogram here, so we'd use the parallelogram. They break this shape down a little bit, so they say that it's a trapezoid, okay? There's a parallelogram there, and then you have this as the area of the trapezoid. So you would use those two formulas and then just go ahead and plug in your numbers. So we have, this is H right here, this is B1, and then they get a little fancy here that you got to sort of figure out what this is. Well, if you take a look if we know that this one is 10 centimeters on the parallel and this is congruent, meaning the same, so this is going to be 10 centimeters, so that means this has to be 10 centimeters also. So that's how we find that out. So you have to sometimes look to other shapes to be able to find your dimensions. You go ahead, you do the calculations, you find the areas, and then you go ahead and you add those two together and you'll find the total. So we look here and we have, in the your turn, we have two problems. We're taking this, we're going to keep this as a rectangle. You find the area of that. You have an area of a triangle and another area of the triangle. But pay attention here, these two triangles are different. You're not going to be able just to flip them together and have one rectangle. This one here, if you take a look, we have a square. And then what's this look like here? Well, that looks like a circle. So if you find the area of a circle, okay, so use area of a circle, but how much of the circle do we have? We have half of it. So once you find the area of the circle, divide that by 2, and then that'll tell you what you have. Then you take your square, you take the area of the circle, add those two together, and you'll find your total area that you have. Here in example 2, they give us a banquet room is being carpeted. A floor plan of the room is shown at the right, so over here. Each unit, so they're talking about the grid, represents 1 square yard. It doesn't say square, but that's what it is. The carpet costs $23.50 per square yard. How much will it cost to carpet the room? So if we take a look here, we have to separate the figures like they tell us. So we have a parallelogram, gives us a rectangle here, and then we have a triangle. So we use our formulas for those three. We go through the calculations, figure out how many square yards in the parallelogram, the rectangle, the triangle, and then we add them together down here. So now we know the total square yards, okay, which is 33, and then you multiply it by the cost per square yard, and you get the total cost. And that's what it's asking. How much will the total cost of the to carpet the room? So here in the your turn, we have a windows being replaced with tinted glass. The plane at the right shows the design of the window. Each length represents 1 foot. Glass costs $28 per square foot. How much will it cost to replace the glass? And they want us to use pi. That's interesting. So if we go ahead and draw this, okay, so we have a rectangle, so we have to find the area. But now take a look at this piece and this piece. What if you took those two pieces and put them together? Don't we now have a circle? So find the area of a circle plus the area, so area of the circle plus the area of the rectangle. And now you'll find the total area, and then you multiply that by the $28 per square foot, and you'll be able to find your answer. Looking at the guided practice, a tile installer plots an irregular shape on grid paper. Each square on the grid represents 1 square centimeter. What is the area of the regular shape? So if I take this, and this is a composite figure, and I break it up, well, okay, I got some things on a slant there, so I'm thinking that that looks like a parallelogram, okay? And then I got this peak up here. I probably could put a line across there. So now I have a parallelogram, I have a rectangle, and I have a triangle. I can figure out the triangle a couple different ways. You have the formulas for the triangle, for the rectangle, and for the parallelogram. You add all of those up together, and you'll be able to go find out what your total shape is there. So I think you have enough information to be able to finish the guided practice. If you have any questions, let me know and I'll help you out in class. Have a good day. Bye.